Hello everyone. Today we're going to be looking at linear inequalities. So this symbol here means less than. This one here means less than or equal to. Less than or equal to. This means, you can probably guess, greater than. And finally, you could probably figure out what that one is. Greater than or equal to. So if you like, a helpful sort of way to remember is think about Pac-Man. It always tries to sort of eat the thing that's bigger. So for example, I could have -2 and -4. -2 is greater than -4, so if you think about like a number line, there's 0, 1, 2, 3, 4, so -2 is there, -4 lives there. -2 is further to the right on the number line than -4 is, so that means this is greater than. Okay, another example, so think about it facing that way, 1.2 versus 0.2, so that one for sure, right? So 1.2 would be just slightly to the right of 1, and 0.2 would be slightly to the right of 0. So 1.2 is bigger, so Pac-Man would prefer to eat the bigger thing. So hopefully that's helpful. Alright, so numbering's a bit off, but never mind that. Determine which of the following statements are true or false. If the original statement is false, rewrite it to make it true. So first one here, we have 3 is greater than 1, and if you think about a number line, right, 0, 1, 2, 3, 1 is there, 3 is there, 3 is to the right of 1, and 3 is bigger than 1, so that is true. Alright, next, -6 is greater than or equal to -4. Is that true or false? So again, you may find it helpful to think about a number line, 1, 2, 3, 4, 5, 6. So -6 is about there, right? And -4 is there. So which one is bigger? That one is bigger, and that is not reflected here. Pac-Man would prefer to eat that one. So this original statement is false. So if I wanted to make it true, -6 versus -4, I could just flip the direction of that. So now it's good. So this is true now. Okay, and last one, 5 is less than or equal to 5. So 5 is not less than 5, but 5 is equal to 5, so that's reflected by this one. So that is true. Okay, moving on. Given the statement x is greater than -5, which of the following x values satisfy the statement? So x is -6. That would be untrue because if we draw a number line, 1, 2, 3, 4, 5, 6, -5 is here, and -6 is further to the left. So we're looking for any x that's to the right of this point. So -4 would be good, -3, -2, -1, 0, and so on. 100, a million, that sort of thing. So this is false because -6 is less than 5. Less than -5. So we require whatever x we put in here to be greater than -5. So -6 in this case is less than 5, so this is not a valid choice, -6. Okay, x equals 0. That lives to the right of -5, so that would be true. And -5 is right on, so that's where it is originally. We require it to be greater than -5 though. So -5 is equal to 5. So this is false. We need an x to be living to the right of negative 5. So, for example, x equals 5.00001 would work. But, sorry, let me try that again. I was just thinking of positive. So x, let's try it different. Sorry about that. Reset. X is equal to negative 4.99999 would work. So that is just very slightly to the right of negative 5. So that is very slightly larger, which is meeting the requirements than negative 5. Okay, numbering's all crazy today. State the inequality that represents, that each graph represents. So filled circle, by the way, filled circle, you need to include that point, and unfilled circle, we need to exclude that point. I guess included and excluded, let's go for that. So everything to the right of negative 2, including, so included this negative 2 as well. So we could state x is greater than or equal to negative 2 for that one. And here, so that would be 1 lives there, 2, 3, 4, 5, and so on. Everything to the left of 1, excluding 1. So x, would this be okay? Is that fine? So why is it wrong? So this equal to thing would be no good. So it needs to be just x less than 1. So now it's good because this matches up with just less than, and then we're good. Okay, next one, graph the solutions to each inequality. So x is greater than or equal to just positive 2. So we're here. Should we fill in the circle? Yes, because we have an equal sign, or equal to, greater than or equal to. And we need to live to the right of 2 and including 2. So we fill the circle. Okay, next one, x greater than 3. So we're here. So we need to be to the right of 3. And do we include the 3? No, because there is no greater than or equal to sign, so we just leave that unfilled. Okay, and last one there, negative 4 greater than or equal to x. So it's a bit weird that the x is written to the right this time. Notice it's on the left each time here. So if you prefer, so x, the greater than or equal to sign, it's wanting to eat this, so the x is less than that thing, so I could just rewrite this if you prefer, x less than or equal to negative 4. So perhaps that seems a little bit easier to interpret. So we're here, and we need to be to the left of that. So less than or equal to negative 4. So we live to the left, and we're also including negative 4 because of that or equal to portion of that symbol. Okay, moving on. So we're looking at adding and subtracting with inequalities. So we basically follow the same steps to solve algebraic inequalities. Algebraic inequalities, as we did to solve algebraic equations, with one small change. We won't be looking at that that small change today. We'll look at that next lesson. So, yeah, that'll be coming up next class. Every step of the way we should work toward getting the variable upstairs or in the numerator. and on its own using opposite, or if you like, inverse operations. So we work through bedmass backwards, which is samdeb. Oh, samdeb. So it's not like so as I mentioned before, it's not a absolute rule to work through samdeb, but it's generally helpful to work through your additions and subtractions first in an algebraic equation, then do the multiplications, divisions, and then finally work toward those things. Just make sure whatever you do to one side, you must also do to the other. When you something both sides, what should go there? When you let's see here, because we're just doing addition and subtraction, we're not going to see this today, but when you multiply or divide both sides of an inequality by a negative number, the direction of the inequality changes. So that's going to be the focus more of next lesson, not so much today, but I'll just give you a little preview of what that might look like. So for example, negative x is greater than 5, for example. So if I wanted to solve this inequality, so if it was just regular x, negative x equals 5, right, we'd divide both sides by negative 1, and we'd get x equals negative 5. Now, because this direction is changing when we divide by a negative, so if I divide both sides of this equation by a negative, I still get x on the left and negative 5 on the right, but the direction of this changes, so x less than negative 5. So, like negative 6 would work, for example. So x equals negative 6 would be a possible solution to this inequality. So if I put negative 6 wherever I see an x in this original equation, I'd go negative 6 greater than 5. So see if that's true. Negative times a negative is positive, so 6 is greater than 5, and that's true, right? 6 is greater than 5. So that's why we need to switch the direction of that thing, because if I ended up with x is greater than negative 5 here, then x equals negative 3 would seem to be a possible solution. But if I put negative 3 into this original inequality, negative 3 greater than 5, so let's see if that's true. Negative 3 is 3, positive 3. 3 greater than 5? No, that is not true. So negative 3 is not a possible solution. So that's why we got to switch the direction. So anyways, we'll get a little bit more time with that tomorrow. So if you didn't quite follow that, that's fine for today, but that is something we'll need to be doing for, I guess, next class. Okay. Solve each of the following equations or inequalities. So we've seen types of things like this before. If we want to get x on its own here, we need to do the opposite of adding 8 to both sides. So we just subtract 8 from both sides. 8 minus itself on the left is 0. And on the right, 3 minus 8 is negative 5. So x is negative 5. And you can obviously test that. Negative 5 plus 8 is indeed 3, so left side equals right side. Good to go. Okay, now we have an inequality, so important, don't freak out when you see this. It's basically the same as an equation, and the direction change won't come up today, so we'll worry about that more tomorrow. So still, we want to get x on its own, subtract 8 from both sides. Because I'm just subtracting 8, I'm not dividing by negative 8. the direction of this thing stays the same. So the direction won't change at all in any of the questions you look at today. It will be an issue next lesson though, so that's something you're going to have to look out for. So 3 subtract 8 is again -5, so very similar to this, but instead of equals we have a greater than sign. X is greater than -5. Okay, and last one here, x minus 8 is less than or equal to 3. So in order for me to get x on its own, so you can sort of, if you like, just sort of treat this as an equal sign. If this kind of makes you uncomfortable, you just got to do the opposite to both sides still. So the procedure is the same, it's just that this symbol is different. So that's the only thing that's different. The symbol is different here, but basically all the things that we'll be doing today, you know, it's not really affected by that. So this will be x less than or equal to 11. So good. So for example, let's see here. So for example, x is equal to, what's less than or equal to 11? So we could do 10, for example. So x equals 10 would be a valid choice for this inequality. So if I plugged 10 in here, everywhere I see an x, I go 10 minus 8 less than or equal to 3. So we want to see if that's true. 10 minus 8 is 2, and 2 is less than or equal to 3. That's a true statement. Okay. If we picked something that was maybe not in line with this, so for example 12, x equals 12, that's outside of this possibility. So let's see what happens there. 12 minus 8, is that less than or equal to 3? So 12 minus 8 is 4. 4 is not less than or equal to 3, so that is no good. Alright, so any number you can think of that's less than or equal to 11 would be a valid solution to this inequality. You could have like 0, you could have -100 in here, -1,000,000, anything, as long as it's less than or equal to 11. Okay, moving on. X minus 7 less than or equal to 4. We add 7 to both sides here. That gives us x is less than or equal to 11. So possible values for x. We could choose so many. We could use 5. We could use -100. We could choose 0. So many. So as long as it's basically to the left of 11 on the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if it's, as long as we're to the left of this on the real number line, it's a valid solution. So everything to the left of 11 works. Okay, next one. 4 plus x greater than 5. Get rid of the 4. The opposite of adding 4, subtract 4. Do that to both sides. So we have x is greater than just 1. So possible values for x. So possible values for x. We could do anything, any number you can think of, any real number greater than 1. We could do 2, 3, 4, 4.5, 100, 1,000,000. Okay, anything greater than 1. Right. Now this one, add 5 to both sides. That gets x on its own. -5 plus 5 is 0. So all that remains on the right is x. this sign preserves the direction because we're not multiplying or dividing by a negative number. So we have x, and negative 4 plus 5 is 1. So x is greater than 1. So it's a bit weird. I mean, if you prefer, you can just do that. So the Pac-Man is eating x in this version, and Pac-Man is still eating x when I wrote the x to the left, so they're equivalent, right? It's probably just a little bit better to express your final answer like this. So again, same possible values, 2, 3, 4, 5, 6, 7, yeah. Any real number to the right of 1. Okay, moving on. So slightly more tricky. We've got variables on both sides. We've got numbers on both sides. We've encountered this type of problem before. The only thing different here is this inequality symbol, but the fundamental procedure is about the same. You want to get x on its own and upstairs. They're already upstairs here. So let's bring all the x's to the left side of this. So what should I do first? I can subtract 6x from both sides. So 7x minus 6x. I have 1x from that result. Still have the 3. Still have this preserved. And that negative 4 needs to come along as well. So we're closer. Got all the x's to the left. Now probably makes sense to bring all the numbers to the right side. So let's do that. Subtract 3 both sides. So 3 minus itself on the left is 0. So I'm left with x. X is less than negative 7. So x is less than negative 7. And here I have a number line with just blanks. So maybe I'll put negative 7 there. Put negative 8 there. Negative 9. I just did a gap between each whole number or each integer just because it just gives me a little more space. So that's why I did that. Negative 11. So less than negative 7, that's where I am. I need to be to the left of that. Should I fill the circle? No, I just leave it unfilled because it is not less than or equal to, right? It's just less than. So if it's less than, I leave it as an open circle. Okay, similar here, variables on both sides, numbers on both sides. Bring the numbers to one side, bring the letters to the other. So let's maybe bring the x's all to the left side. So 1.4x minus itself on the right is 0. And 2.4 minus 1.4x is just 1x plus 3.2 greater than or equal to 5. So now I have a bit closer. I need to get rid of the positive 3.2. So the opposite of adding 3.2, subtracting 3.2. I need to do that to both sides. 3.2 minus itself is 0. X remains on the left. X greater than or equal to, what's that? 1.8. So 5 subtract 3.2. 5 subtract 3 would be 2. And then 2 subtract 0.2 would be 1.8. Alright. So let's maybe put 1.8 there. I'll put 1.9 there, 1.10, so 2, 2.1, 2.2, so on, 1.7. So we're here. We need to be greater than, so we need to be to the right of 1.8, and we're greater than or equal to, so we should fill this circle. Good. Okay, nearly done. Sarah currently has a balance of $750 in her account. She must maintain a minimum balance of $1,000 in order to avoid paying a monthly fee, write an inequality. So that's like, one of those or one of those, describing this situation. So we'll let X represent the amount she needs to deposit. So we need to be, all right, so if she has $999 in her account, she will pay a monthly fee. If she has $999.99, she would probably still be paying a fee if they're not rounding to the nearest dollar. So we can have $1,000 in our account, and then we won't pay a monthly fee. So as long as we have greater than or equal to $1,000, we're good to go, no monthly fee. So in order for her to reach 1,000 from 750 plus some number, that's the amount she needs to deposit. That'll make her greater than or equal to 1,000. Okay, so next we're going to solve the inequality. So just maybe bring that down here. So same, solve for x. So we need to get rid of the 750 on the left, subtract 750 both sides. So 750 minus itself is 0. We got x greater than or equal to 250. So if she deposited $250, that'd be good. If she deposited 251 or 252 or 500 or 1,000 or 10,000, as long as it's greater than or equal to 250, we're good to go. So maybe go 250 there. We could do maybe 260, 270, 280, 290, and so on. Okay, so we need to be bigger than or equal to 250, so we need to be to the right of that. And equal to works as well, so greater than or equal to, we fill that circle, and that's it. Okay, your assignment for today, you can work through these questions, please. And there will be something available for you to work through, just maybe a short bit of work based on these questions. So please do these first, and then you can work through the assignment posted online. So that's it for me for today. I'll see you next time.